Welcome to Parker Pneumatics I/O Link video. This video will review 4 key points: why your customers are interested in I/O Link, what you need to know about I/O Link, why is I/O Link growing, what does it mean to pneumatics. I/O Link is a cost-effective solution because it is simple to use with multiple manufacturers' components. It offers inexpensive point-to-point connections over the I/O Link protocol versus traditional industrial Ethernet protocols. I/O Link enables smart products, diagnostics. There are 124 companies active in the I/O Link community. There are over 300 I/O Link products available in the market today, primarily sensors. I/O Link reduces the average I/O cost point from $8 to $10 to $6 to $8 via its open protocol, ease on configuration, self-parameterization, and the use of standard cabling. I/O Link enables smart products. In this example, I/O Link provides diagnostics data capability for a photoelectric sensor. I/O Link provides diagnostic process, service, and parameter data capabilities for smart products. In this example, I/O Link diagnostic data provides data monitoring, diagnosis, sensitivity and teach, light on, dark on selection, switching the timer, sensor mode, sequence selection, detection counter, and temperature. With I/O Link, you can read and change device parameters through the control system software, enabling faster configuration and commissioning. An example of how I/O Link enables diagnostics in sensors. Previous situation: it was not possible to tell if a sensor lens is dirty until the sensor fails to sense the target. With I/O Link, excess gain information can be used to check for dirty lenses. Since I/O Link can provide real-time and historical data over the I/O Link network, this ensures smooth operations. I/O Link enables automatic devices replacement. Situation today: personnel needs a manual to reprogram a sensor or requires a laptop with programmable software. With I/O Link, sensor automatically restores sensor parameters when connected. I/O Link is a communication system for the connection of intelligent sensors and actuators to an automation system in the IEC 61131-9 standard under the name of the I/O Link Digital Interface for Small Sensors and Actuators, SDCI. The standardization includes both the electrical connection data as well as a digital communication protocol via the sensors and actuators, which can communicate with the automation system in data exchange. I/O Link is a point-to-point communication and not a field bus. The I/O Link Master establishes the connection between the I/O Link devices and the automation system. As a component of an I/O system, the I/O Link Master is installed either in the control cabinet or as a remote I/O with enclosure rating of IP65-67 directly in the field. The I/O Link Master communicates over various field buses or product-specific backplane buses. An I/O Link Master can have several I/O Link ports, channels. An I/O Link device can be connected to each port, point-to-point communication, since I/O Link is point-to-point communication between sensors and actuators. So, 2 I/O Link devices need 2 I/O Link master ports, 3 devices need 3 ports, etc. It is an open protocol which can connect directly into an industrial Ethernet protocol such as Ethernet IP or Profinet, using standard versus proprietary cables. I/O Link uses standard non-shielded M12 cables with 3, 4, or 5 wires. I/O Link masters can be IP20, connected to a PLC and mounted in an electrical enclosure, IP65 like Parker's, or IP67 mounted on a machine. Master devices include PLC masters or I/O Link M12 or M8 I/O blocks. Slave devices include pneumatic valve islands, sensors, regulators, pressure and flow switches, lights, and several others. From a hardware standpoint, I/O Link is just a chip shown next to a penny to show the size of the chip. The chip allows communication on the 4-pin as opposed to an on-off like a traditional sensor switch. Applications include industrial sensor, actuators, PLCs, and remote I/O. Voltage equals 24 VDC. Cable length can be up to 20 meters. Connectors can be M5, M8, or M12. The topology is point-to-point. Data transfer rates equal 4.8K, 38.4K, and 230.4K bauds. The cycle time can be as fast as 2 milliseconds. There are two primary reasons to switch to IO-Link. 1. Save money versus using industrial Ethernet. 2. Attain better performance and diagnostics than hardwiring. IO-Link is cost-positioned in the middle ground between hardwiring and industrial Ethernet in situations where valve islands are connected to a node. IO-Link has the benefit of simplifying wiring like an Ethernet node on the manifold at a much lower cost point. We expect to see customers pushed to IO-Link for valve islands in order to lower hardware and installation costs versus industrial Ethernet and to get diagnostic data via a Class A or Class B IO-Link connection. Class A. Communication and auxiliary power are supplied through two separate M12 connectors. Class B, communication and auxiliary power are supplied through one M12 connector. And we can just connect onto those free Open IO-Link master ports to get our valve on the network at half or a third of the price of a node.